Hello, everyone. This is Nu Ye from Nanyang Technological University in Singapore. In this talk, I will present our work on a model-based testing platform for smart contracts. This is a collaboration between NTU and WeBank. Smart contracts are computer programs running on blockchain platforms such as Ethereum and EOS. Specifically, users can interact with smart contracts by sending transactions to them. The execution results of the transactions will be stored in the blockchain and remain immutable, which makes smart contracts suitable for trustless scenarios across multiple users. However, there exist a lot of challenges in smart contract testing. Here is a real-world smart contract application, CMA, used by WeBank for supply chain management. But the existing testing approaches do not perform well on this enterprise application. These approaches lack understanding of stateful behaviors, and also the functional correctness cannot be checked due to the absence of test oracles. Moreover, existing measurements of test adequacy usually consider branch or path coverage, which miss the coverage on system behaviors. Intuitively, based on a specification model like the CMA's state diagram, we can test smart contracts more effectively and efficiently. In our work, we aim to automatically test smart contracts using model-based testing. Models can be used to represent the desired behavior of smart contracts, as well as the testing strategies and a test environment. At the front end, users first deploy contracts to the blockchain. Users should provide specifications for their smart contracts. We build the contract model on the specification, then generate the test cases. Further, each test case will be encoded in a transaction which will be executed by the blockchain. The execution result will also be monitored. Users will check if there are any violations against models or other security patterns. Moreover, at the front end, users can determine which strategy can be used for test case ordering and selection. Here we demonstrate how to use ModCon website. We introduce a step-by-step walkthrough of ModCon on the aforementioned credit management application, CMA, mentioned in the paper. The basic workflow of ModCon consists of 3 steps, namely, contract setup, test model specification, and test generation. ModCon has 2 work tabs, namely, the Home tab for contract setup and the Test tab for customizing specification and testing. User first sees the Home tab containing a contract setup configuration panel. The panel has a files uploading dialog and presents possible error messages in the results section. User uploads 7 smart contracts of CMA to ModCon server. You can see credit map, credit controller, and other contracts has been uploaded. Uploading these contracts usually spends less than 10 seconds. Once done, user can compile the contracts. User clicks Compile button to compile CMA. The compilation would spend around 1 minute. Once compilation succeeds, user can go to next step to deploy CMA application. User can select which smart contract to deploy and specify constructor arguments in inputs field. CMA application requires a little complicated deployment configuration. CMA first creates account controller instance and uses the instance's address as the constructor argument to deploy credit controller, which is the main target contract. User clicks Deploy button, then credit controller will be deployed. Apart from smart contract deployment, user can send a transaction to the deployed smart contract instance. Since every credit instance within CMA belongs to some account, to make CMA works well, user selects contract account controller and its instance address and OBI function register account. User specifies valid 4 parameters of function register account. Once given the inputs, user can click Send TX button to send a transaction to blockchain and a valid account will be registered. User clicks on the Test tab to open the test view. At the second step, user selects the CMA test model specification from the drop-down menu, which include a number of predefined examples. The specification content lies on the left side, and the middle pane is the control panel for configuring test generation and progress monitoring. The right side shows the model driver generated from the specification automatically. User may customize the model driver accordingly. At the last step, user specifies test coverage strategies and priority options. Users first select cover state strategy and choose some state or transition priorities. User can export the test results into a CSV file. User can examine the testing goal by seeing what transitions or states are activated in the dynamic state machine graph. Now all the states are covered, spending around 60 seconds. Let's try the second strategy to cover transition. You can see all states and transitions are covered in 200 seconds, other than transfer loop transition. Let's try the third strategy to cover the transfer transition. As shows in graph, now we have covered transfer transition. We have demonstrated the usage and key features of ModCon on the CMA application. That's all. Thanks for your watching.